Hello, good morning students. See, this is our 12th lecture of statistics chapter number 3, measures of central tendency. See, in our last lecture we complete our illustration number 28. So here we can say that mean, median, mean, median, quartile, decile and percentile we are completely. Okay. So mean, 10th method of mean, the 3 method of median and then 3 method of quartile, decile and percentile here we completed. And in our last lecture I told you that you have to do exercise 3.4 1 to 5 questions. You all do this, I think so you all do this completely, and if you have any doubts then ask me or WhatsApp me. Okay, now today we will start with our next topic, or you can say next measure of central tendency, that is mode. See here, mode. What is that? See here, mean, median is usually used in everywhere, but these measures is used in a business, or you can say commercial field, right? It is often used in business and the commercial use. That's why here we are understanding, and because we are the commerce student, we have to understand this measurement. Okay, so now I am reading the meaning of the mode. Meaning, on the page number 99, that is 99, the value which gets repeated maximum number of times. See, the value is repeated maximum number of times. That means into the ungrouped data. See, into the ungrouped data, the value which is repeated maximum times, it is called a mode. Or into the discrete or continuous group data, what is that? Or the value occurring with a maximum frequency. See here, whenever frequency is given, it is called discrete and continuous group data, right? And on that, whenever the discrete or continuous group data is given, we have to show the maximum frequency observation, right? So the value occurring with the maximum frequency in the given data is called as mode. Okay, so it is denoted by MO. Mode is equal to, we can say, MO. See, median is equal to what? Capital M is equal to median. Mean is equal to what? X bar. Mean is denoted by X bar. Median is denoted by capital M. Now the mode is denoted by MO. So here the slight difference between M and MO. See here, median is equal to capital M. That means mode is equal to MO. Right? So you have to keep in mind that it is denoted by capital M, or you can MO, not MO but M0. Okay. Now see the methods. Now I am writing the methods to find out the mode. First method, for ungrouped data. See, again we have to find out the as well as mean, median and mode. Now mode with the ungrouped data, mode for the discrete group data and mode for the continuous group data. And all the have 3 different formulas. That is, ungrouped data has different formula, discrete has a different formula, as well as continuous has a different formula. Now mode is equal to what? Maximum repeated observation, that is mode. Mode is equal to, here see I am reading that calculation of mode on page number 99 for the raw data and for discrete frequency distribution for both. First of all, for the raw data, in this case the mode can be found simply by inspection. See, we can find out the mode, not by calculation, by only inspection we can say that this one is your mode of this data by just inspection, right? We can find out the mode as a value among the observations which is repeated maximum number of times or the one which has maximum frequency, right? So here you can say that for ungrouped data, MO, for ungrouped data, MO is equal to maximum repeated observation, right? Into the raw data, into the ungrouped data, whatever observations are given, the observations which is repeated highest time or maximum time, it is called your mode. We don't have to calculate anything into the calculation of mode. We just have to inspect that which one is the highest repeated observation. Okay, and the second method for discrete group data, MO is equal to what? Maximum frequency observation. The frequency, highest frequency observation, right? So here, whenever, see, I'll give you here the example 0, 1, 2 and 3, that is your X, and the frequency of that is 10, 15, 20 and 5. So here the highest frequency, you have to first of all find out the highest frequency, maximum frequency, or you can say highest frequency. Which one is that? That is 20, right? And for that the observations, corresponding observation is 2. That's why we can say that highest frequency observation, that is 2, is your mode for this discrete group data. Okay, and for this I am giving you an example also. Here 2, 3, 5, 8, 2, 4, 3, 2, 8, 5, 2 and 4. See here, this is the data. In that 2, 1, 2, 3, 4. 2 is repeated 4 times, 3 is repeated 2 times, 5 is repeated 2 times, 8 is repeated 2 times and 4 also repeated 2 times. All other observations are repeated, but the highest, see, the mode is minimum, mode is equal to maximum repeated observations, right? What means of that? Here 3 is also repeated, 4, 5, 8 all are repeated, but 2 is repeated 4 times and the other is repeated only 2 times. Then we can say that mode is equal to, mode of this data is equal to 2, because, and here the mode of the data again 2. Why? Because 2 is repeated 4 times, maximum repeated observation, not repeated observation, maximum times, right? 2 is repeated 4 times and the other is repeated 2 or 3 times, right? That's why here the data mode is equal to 2, and here in this data the mode is equal to again 2, because the highest frequency observation is there. Okay, now see the continuous group data. We'll see after the some examples of these ungrouped or discrete group data. See here, I am reviewing this. Please write down these in your fair book. If you miss that, then repeat the video. Please write down this formula, right? Okay. Now I am reading the next example, that is example number 29. The number of books purchased by the each of the 15 persons from a bookstores are as follows. See, we have to write the observations, all the observations. One, 0, 2, then again 2, 3, 4, 2, 7, 2 times 2, 5, 4, 2, 1 and 2. See here, find out the modal value. See, not mode, here they ask modal value, both are same. If they ask that find out mode, then you have to find out MO, or if they ask that find out the modal value, that again you have to find out mode. Okay, find the modal value for the number of books purchased. Here, see, we don't have to calculate anything into the mode. We just have to see that which observation is highestly repeated, because it is an ungrouped data, right? So you can easily say that, sir, 2 is a highestly repeated or maximum repeated observation. Yes, that's why here we have to write MO is equal to maximum. We have to write the formula maximum repeated observation, and that's why therefore MO is equal to 2 for this data, because 1, 2, 3, 4, 5, 6 and 7, 2 is repeated 7 times in this data. That's why the MO for this data or modal value of this data is 2, right? See the answer here. We can see that the value of 2 is repeated 7 times, which is more than the number of repetitions of the any value of the other observations. Hence, the mode of this data is equal to 2. Okay. So now the next illustration, that is illustration number 30. It is easy and it will ask in 1 or 2 marks only, right? So here next point, illustration 30. TV sets assembled by a TV manufacturing company in a month are tested. The following table shows the number of defects per TV set, right? Find the mode of the number of the defects. Here number of defects, that is 0, 1, 2, 3, 4, 5. Here the data is given. You can see that the data is discrete group data, right? Here 0, 1, 2, 3, 4, 5, that is your X, and here number of TV sets, that is your frequency. See here, see, this is the X and this is your frequency, but you can say by the meaning, or you can say by the main formula of mode of discrete group data, that which one is your mode from this data, highest frequency, or you can say maximum frequency observation. What is the formula for that? MO is equal to maximum frequency observation. So here you can say that 45 is the highest frequency. 45, 22, 18, 10, 6 and 4. That's why you can say 45 is the highest frequency, and the corresponding observation is 0. That's why you can say here MO is equal to 0 as per the definition, or you can say as per the meaning or as per the formula. Here the MO is equal to 0, but see, here we are finding out the measures of central tendency. What means of that? Central tendency means the data central value. See, the value of the data. Central tendency means what? We are finding out the value of the center that means mean, median or mode. 3 or quartile, decile, percentile, all are the value of central tendency. Okay, but we can say that here this one is the beginning data's beginning observations, right? So we cannot say that this one is the measures of central tendency, or you can say that this is not perfect answer. See, this is not perfect measurement for the central tendency, because this data is the beginning data, not a central data, right? That's why we can say that this method is not appropriate here. See, the question asks us to find out the mode, and we just know the two method here only. For that, maximum repeated observation for ungrouped data and maximum frequency observation for discrete group data. So here we can say that here 0 is the answer as per the regular formula, but here it is not an appropriate answer. Why? Because it is not a central answer, it is a beginning answer, right? That's why we cannot say it's an appropriate answer. We have to find out this by the next formula, that is empirical formula, and which we will discuss later. That is after third method we will discuss the fourth method, that is the empirical formula of the mode. Okay, so here this method is not appropriate for this, but if we have to find out this, then the answer is okay. But you have to say that the empirical formula is best part for this type of questions, and we have to find out the mode by that formula only. See, read the note under that, under the question number, illustration number 30. Read again. I am reading that note. According to the definition, the value of the mode in this illustration is 0. Yes, but it cannot be taken as a measure of central tendency for the data, as the value of the mode is in the beginning of the data. See, it is not into the central. It is not into the center, but it is in the beginning of the data. That's why it is not called a measure of central tendency, right? See again, next paragraph. Mean or median should be chosen as a measures of central tendency for the such data. See, mean or median, if you want to find out the central value of these, you can use mean or median, or the value of mode should be find out. Or if you want to find out the mode only, not mean, not median, you have to find out the mode only, then you can use the empirical formula, that is based on mean and median. See, again, if you want to find out mean and median as a central tendency measurement, then it is okay for this data. But if you don't want to find out mean or median, you just have to find out mode, then what? Then you have to say that you have to first find out mean and median, and then use the empirical formula for mode, which we discuss later. Okay, see, at that time I also remember this example. Okay, now see, now next illustration, that is illustration number 31. The number of trips made by 24 taxi drivers in a day are shown in the following data. Find the modal number of trips. Modal number, that means here you have to find out the mode. Okay, now see here, number of trips 1, 2, 4, 5, 6, 7. That is your X, right? And the number of drivers 3, 7, 4, 7, 2, 1. See, again, the twist is that here the data is in, the answer is in the beginning. Now see here, I am removing that example 30. Now I am writing here example 31. See, the data is number of trips, that is 1, 2, 4, 5, 6, 7. And number of drivers. Three, 7, 4, 7, 1. See here, what is the answer for this? This is again a example of discrete group data, and for example of discrete group data we have to use the formula of maximum frequency observation. Right here, see the frequency, this is your f and this is your x. Maximum frequency you have to see here, that is 7, but it is 2 times. Maximum frequency here 2 times. You have to say that here in this data there are 2 modes. Therefore, mode is equal to maximum frequency observation. Maximum frequency is 7 and it is 2 times. So the corresponding observations is 2 and 5. So you can say that in this data there are 2 modes, 2 and 5. But it is not a perfect answer. There is only one answer, right? So here again, at this type of data we have to use the empirical formula, right? Here I am reading the answer. See, the maximum frequency is 7, which is frequency for the observation 2 and 5. Hence, we can say that this distribution has 2 modes, that is MO is equal to 2 and MO is equal to 5, or you can say MO is equal to 2 or 5, right? Thus, the model for the number of trips by the taxi driver are 2 and 5, but here node, see the node, such a distribution is called a bimodal distribution. Similarly, there can be a distribution with more than 2 modes. Whenever the distribution is given here with the bimodal distribution, or you can say more thus the modes for the number of trips by the taxi driver are 2 and 5. And see the node, such a distribution is called a bimodal distribution. Similarly, there can be a distribution with more than 2 modes. Here, whenever the distribution is given with the more than 2 modes, then you can say that you can find out the mode with the empirical formula, not with this formula. Okay? Okay. But at the time of empirical formula, I am giving you the tips, or you can say I am giving you a points which when we have to use the empirical formula. In which situations? See, there are 4 or 5 situations is there. That means the data is given, you have to see the data, you have to inspect the data, and then you can find out which method you have to use. If it is come under the 4 or 5 situations of empirical formula, then you have to use that particular empirical formula, or otherwise if it is a normal one, then you can use these formulas for the ungrouped data, for the discrete group data, as well as for the continuous group data. Okay, so here these were the examples of the discrete group data and the ungrouped data. And again, one extraordinary example is given in which you can say here also we can use the empirical formula, not a regular formula. See, the situations are different situations is given in the different examples. Next, illustration 32, I am reading that the number of patients arriving at a clinic each hour during the working hours of a day are recorded as follows. See, the data is given. Here I am writing illustration number 32 because it is very small. See, the data is given 3, then 5, then 4, then 2, then 7, and then 8. Right? Here, which type of data is that? Here it is an ungrouped data. Right? And what is the formula for ungrouped data? Maximum repeated observation. Right? For that, here MO is equal to what? Maximum observation. But here no observation is repeated. 3, 5, 4, 2, 7 and 8. All the observations comes once in the data. Right? So here we can say that here no mode of this data. See the answer. As all the values are appearing only once, we cannot find out the most common observation, or we can say most repeated observation from this data. Hence, the mode for the number of patients cannot be found from the given data using the definition. Underline that particular word. We cannot find out the data's mode, because here we cannot find out the mode by using definition, or we can say the meaning, or you can say the formula. Maximum repeated observation is the formula, is the meaning, is the definition, and we cannot find out here the mode from this data by using this. Okay, so you have to write as per the as the answer of this example 32, that we cannot find out the mode as per the definition. So it can be said that we can find out the mode by using the other formula, by not by definition, by other formula, and that one is empirical formula. We will discuss later after the continuous group data's mode method. Okay. So here all different situation sums, ungrouped data, discrete group data, continuous group, ungrouped data and discrete group data, both data different frequency is given, different situation is given, and different types of question we show here, that is 4, 29, 30, 31 and 32. 4 examples is here. You have to write all these example into your example book, right? And now we will continue with our continuous group data, but first of all you have to write down this. I am giving you here 2 minutes for the writing out this, and show again and again these 4 sums. Okay. Okay, now see, we will start with our next method for the continuous group data. See, I am removing this. Here the method number 3. For the continuous group data, see, we have to find out first modal class. See, in median we have to find out, or in median, in quartile, in decile, in percentile. First of all we are finding out the class of that modal, or median, quartile, decile or percentile. Here we have to first of all find out the modal class, that is MO class is equal to maximum frequency class. See, MO class. First of all we have to find out the modal class by using this formula, that is highest frequency or maximum frequency class is your MO class. And now the original formula for MO, that is what? L plus Fm minus F1 upon 2Fm minus F1 minus F2 into C. This is the formula L plus, as median, quartile, decile, percentile formula, we have to write down here first L. L means what? Lower boundary point of that model class. So here where we have to write down all these things, where L is equal to lower boundary point of model class. Second one, FM, maximum frequency of a model class. See, maximum frequency class is our model class. That's why here you can say FM is equal to maximum frequency or model class frequency. Frequency of model class, or you can say the highest frequency you have to write, maximum frequency you have to write as FM. Now F1 is the frequency of the class prior to model class. Please write down this formula and these details in your fair book. F1 is equal to frequency of the class prior to model class. That means what? Here in the median, quartile, decile, whatever we are writing as a CF, cumulative frequency in the formula, that is the cumulative frequency of the previous class or prior class of the particular model or quartile class. Here again F1 is equal to frequency of the class prior to model class. Now the second one, F2, is the frequency of the class succeeding to model class. Frequency of the class succeeding to the model class. And the last one is C. Again C is equal to class length, or you can say class interval. Of model class. See here I am giving you the example of that. Here the class is given 0 to 10, 10 to 20, 20 to 30, 30 to 40 and 40 to 50. Now the frequency is given 10, 12, 15, then 18, sorry, not 18, only 10 and then 8, right? So here which one, first of all, the class of model class is equal to maximum frequency class. So here see that 15 is the highest frequency, or you can say maximum frequency, and that's why here the model class is 20 to 30, right? So for first of all we have to find out the model class, maximum frequency class. Maximum frequency is 15, so model class is 20 to 30. Then you have to use this formula, that is MO is equal to L plus. L means what? Lower boundary point of model class. See here it's an 20, right? Exclusive data, that's why 20 is your L here. Then FM, maximum frequency, or you can say frequency of a model class. Which one is that? FM is equal to, see here L is equal to 20, FM is equal to 15. Why? Maximum frequency is here 15, or you can say the frequency of a model class is 15. Now F1, frequency of the class prior to model class. See, prior to model class, that means this, and succeeding to model class, that means this, right? Prior means previous, succeeding means next. What is the F1? Here F1 is 12 for you. For this data, previous class or prior class frequency, that is 12. So F1 is equal to 12 in this data. F2 is equal to frequency of the class of the succeeding to the model class. Model class succeeding, that is next. Next is 10. So here the 10 is the F2. This one is F1, this one is F2, and this one is FM. Always in the continuous group data sum, the maximum frequency is equal to FM, previous class is equal to F1, and next class is equal to F2, right? And the class length is 20 to 30, that's why 10 again. That is class length of the model class is 10 because 20 to 30 is the data, right? So here these are the, see, I am giving you this example to understand this formula only, right? So you don't have to write these, you just have to write only this formula into your fair book. So first of all, write down this formula and then we'll discuss. See, the graph is not important here, and that's why we are skipping out it, and we are continue with the illustration number 33. See, I am reading the illustration. The following table gives output of workers in a factory. Find the modal output. Whenever the word modal or mode, you have to find out the mode. Okay. Output, number of items, 150 to 160, 160 to 170, and so on. That is your data, that is your class. And here number of workers, that is 4, 5, 19, 13. See, these are the frequency for you. You have to find out from these the mode. Okay, so I am removing here and I am doing the illustration number 33. Output, number of items, that is 150 to 160, 160 to 170, and so on. See, you don't write like this, you have to see the data first, because sometimes the class length is not equal. So you just have to care in seeing the questions or reading the question. 150 to 160, 60 to 70, 70 to 80, 80 to 90, 90 to 200, 200 to 210, 210 to 220, and 220 to 230. Okay, so here the data is in continuous form, but sometimes it is not. So we have to be careful about that. Now number of workers, that is your F. Frequency 4, 5, 19, 33, then 48, 22, 12, and 6. See here, we don't have to make any total, we don't make to have any new column to find out the mode. See, in continuous group data, if we want to find out mean, then we have to find out first mid value, then di, then FIDI, right? But here and in median, we have to write down one extra column, that is cumulative frequency. That means whenever you have to find out mean, you have to make the 2 or 3 extra columns. Whenever you have to find out median, quartile, decile, percentile, you have to make one extra column, that is cumulative frequency. But at the time of finding out mode, you don't have to make any column into the question. Here the question is here, and you just have to write the answer. That is, you just have to calculate the different things, that is formulas, nothing else. You don't have to make any extra column to the question. Now see the answer. First of all, we have to find out MO class, that is class of maximum frequency. See, highest frequency, which one is the maximum frequency? The 48 is the maximum frequency here, 4, 5, 19, 33, but 48 is the maximum frequency, and corresponding class, that is maximum frequency class, is 190 to 200. Therefore here you can say that MO class is equal to 190 to 200 is the model class of maximum frequency, and here the maximum frequency is 48. That's why you can say 190 to 200 is the model class. See the answer on page number 101. The maximum frequency is 48 for the class 190 to 200. Hence, the model class is 190 to 200. That's why we have to write like this. Now, put the formula here. What is the original formula for MO? L plus Fm minus F1 upon 2Fm minus F1 minus F2 into C. Right? This is the formula. Now, what is L here? Here 190 to 200. See, it's the exclusive data. So 190 is your L. 190 plus maximum frequency means what? See here, this one is your Fm, this one is your F1, and this one is your F2. Right? So here, what is your Fm? 48, maximum frequency, or you can say the frequency of a model class, that is 48, minus F1, that is prior class to the model class frequency, that is 33, previous class of the frequency, model class of the frequency, 48 minus 33 divided by 2 Fm, that is 2 into, here again Fm is equal to what? See, first of all, I have to write all these things. See here, I am writing this. What is your L? L is equal to 190. Then what is your Fm? Highest frequency is 48. Then what is your F1? F1 is equal to 33. What is your F2? Next of frequency, that is 22. And what is your class length? That is 10 here. So first of all, I have to write that all these things, whatever we are using into the formula, we have to write down the values. Now MO is equal to, put the value here, 190 plus 48 minus 33 divided by 2 into 48 minus 33 minus 22 into C, that is 10. See here, 2Fm means 2 into 48 minus F1, that is 33, minus F2, that is 22. Right? So now simplify here. 190 plus 48 minus 33. What is the answer? See here. It is 15 divided by 96 minus. See, minus minus plus plus, the sign is minus. So here minus minus plus, but the sign is minus, minus 55. 48 2s are 48 into 2, that is 96. And here minus minus plus, that is 33 plus 22, that is 55. But we have to put the sign of the maximum number, the highest number, that is minus. Minus 55 into 10. So here 190 plus 15 into 10, that is 150 divided by 96 minus 55, that is 41. So 190 plus 150 divided by 41, 3.6585. So the answer is 193.66. Your modal value, approximate value. Approximate value of the modal class or modal output is 193.66. So you have to write that. Thus the modal output is 193.66 items. Okay. So here your sum is complete. But here see that, first of all write down this. And if you have any problem, then please see this video again and again. What is L, what is FM, what is F1, what is F2, and what is C. Right? See this video again if you have any problem, or ask me. And write down this into your fair book. Now here see, we complete into our this lecture illustration number 29, 20, 30, 31, 32, 33. That means ungrouped data, discrete group data, and continuous group data. All the different situations of ungrouped and discrete group data, and only one situation, only one, that is simple situation of a continuous group data. Okay, now we will see in our next lecture the different situation of continuous group data, other different situations of continuous group data to find out the mode. Okay, so here the time for homework. See the homework. See on the page number 109. First question. The IQ level of a student in a class are given below. Find the modal value. See, this is the ungrouped data. So here your homework. Exercise 3.5. Question number 1 is your homework because it is ungrouped data and you have to find out the mode. The second one, find the mode. This one is the discrete group data. So again, you can find out these also. Second is your discrete group data mode. Now the third one, 50 to 60, 60 to 65, 65 to 70, 70 to 85, 85 to 100. See here. See, the distribution of the age of 48% in the old age home is given below. See the here. Class length is equal 10, 10, 10, 10. So you can see that here it is a normal data. But here into the third question of exercise 3.5, 50 to 60, that is 10 class interval, then 60 to 65. The class interval is changed here. So in this case you cannot find out the mode from this formula. You have to use the empirical formula. That's why skipping that here. Okay, now Next one, you cannot use that also. Okay. Okay. Fifth point, fifth question is your simple question. Weight of apple in gram: 120 to 130, 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80, and 80 to 90. So it's a normal question. It's just like this. That's why you can do that sum also. So in short, you have a 3 sums only into your exam, into your homework. Exercise 3.5, question number 1, 2, and 5. Please do your homework and write down these all the formulas and examples in your example book, and all these exercise sums in your exercise book. Okay, here and completing my lecture. Thank you, class.